In the last video, we looked at some revision on circle theorem. In this video, we're going to do a range of questions that involve using circle theorem. We'll never be able to get through all of the possible questions that could come up, but hopefully this video will give you the skills required to tackle any that might come up. So let's start off. In question 11, we're told a circle with centre 6, -1 passes through the point T, which has coordinates -3, 2. We're asked to find an equation for the tangent to the circle at the point T. Okay, let's just draw this up. A tangent is just a straight line, and that can be written in the form y is equal to mx plus c. So just drawing this up, I'm going to have now the centre, which is 6, -1, and then I'll have a point T, which I'll put just here. Now this doesn't have to be massively accurate, it's just giving me some visual representation of what's going on. I'm going to put the tangent on. The tangent is a straight line that just touches the circle. From our circle theorem, we'll know that the tangent and the radius create a 90-degree right angle, or if you like, they're perpendicular. So I just need the equation of this tangent. Now that can be written in the form y is equal to mx plus c. All we need is a gradient, which I can find, and a point. I already have the point, so we need to find the gradient. What I'm going to do is find the gradient of the radius, and I'm going to call that mt. Then mr, gradient of the radius, and then mt, which is the gradient of a tangent. If perpendicular, mt times by mr will be equal to -1. We've learnt this in a previous unit. When you multiply the gradients of two perpendicular lines, we end up with -1. So let's look at the gradient. The gradient m is the change in y, so y1 minus y2, over the change in x, x1 minus x2. So let's get a gradient for the radius. So the gradient of the radius, mr, is going to be -1 subtract 2 over 6 subtract -3. So this is going to be -3 over 9, which we can write as -1/3. Therefore, the gradient of the tangent will be the negative reciprocal, which is going to be +3, or +3 over 1. So let's go ahead. I'm going to use the form y minus y1 is equal to m, the gradient, x minus x1. So we'll have now y minus the 2. That will be equal to 3, and then we'll have x subtract -3, which is +3. You can, of course, use y is equal to mx plus c. I prefer this particular method. So the gradient of a tangent is 3. I've got my point here. I just sub in. So y is equal to 3x plus 9 plus 2, which is 3x plus 11. So that is done. You can see here a sketch really does help out. In question 12, we're told a tangent to the circle C at the point P passes through the point Q, which has coordinates 10, -3. Given that the equation of the circle C is x minus 2 all squared plus y plus 1 all squared is equal to 16, find the length of PQ. There's lots of different things that we need to take on board here. What I'm going to do is use the fact that the radius and the tangent are at right angles, and then all I'm going to do is use Pythagoras Theorem. If we look at this circle, we've got the centre of 2, -1. We've learnt that in a previous video. So 2, -1. I'm going to put a point here, and that's going to be the point P. I'm going to put over here the point, and I'll just put this on here. I'll put this as Q, and Q has the coordinates 10, -3. So all I'm going to do, and of course I could put P here, it really doesn't matter. I'm going to put the radius on the circle. We can see that the radius squared is 16, so that means that the radius is 4. I'm now going to put a line from the centre of the circle out to Q. And finally, I'm going to put a line from P to Q. Now that line doesn't have to be extended as I have. I'm just showing that that's going to be a right angle, as this would be a tangent. Let's just put that on there. Okay, so we've already learned that these create a 90-degree right angle. So that'll look something like that. Again, it's just a sketch. So let's go ahead and put this on. So what we need to do is find this length right here. And this length, let's just call that x. We can find the length of now the centre to Q by using the distance formula. So we can say that the distance is going to be the square root. Now, in general, it's x1 minus x2 all squared plus y1 minus y2 all squared. And we've seen this in the video before. So the distance from here to here is going to be now the square root of 10 minus 2, which we need to square, plus negative 3, and we're going to subtract from that negative 1, and we need to square that. So that is going to give me now the square root of 8 squared, which is 64, and then we're going to have negative 2 squared, which is going to be 4. So that is going to be the root of 68. Okay, so if I just put this is a root of 68. This is where Pythagoras Theorem comes in. I've got now this length, I've got the hypotenuse, I need to find a shorter length. So by Pythagoras we can say x squared plus 4 squared is equal to root 68 squared. So if I just put that on, that's going to be 68. So if we consider x squared is going to be equal to 68 minus 16, which is 52. So x will be the positive root of this. The square root of 52 should give us 2 root 13. It's 4 times 13, but of course we can check if we wanted to find that out. And that's in exact form. So 2 root 13 is that length right there. So all I've done is use Pythagoras. So there we go, quick sketch, circle properties or circle theorem, and then we go ahead and solve. As you can see, a sketch must really be put in place for that to make sense. I could of course have P somewhere out here, it really doesn't matter, as those are congruent or congruent triangles. We can see that that would be 4, this would be the same line, they share that one, and we would simply be finding that one. So if I wanted, I could write now that this point here was P. Okay, so that could have been P. Doesn't matter, we've gone ahead and done that. We've not been asked for the coordinates. Okay, let's move on and look at another one. In question 13, we're told a circle has equation x minus 3 all squared plus y minus 5 all squared is equal to 100. We're in part A asked to show that the points P, 11, negative 1 and Q, negative 3, negative 3 lie on the circle. All I'm going to do is substitute these in. So what we'll have is 11 minus 3 all squared plus now y, which is negative 1, subtract 5 all squared. That's 8 squared, and then this is going to give me now plus negative 6 squared. 64 plus 36 is equal to 100, therefore it's on the circle. Let's do the next one, negative 3, and we're going to subtract now 3. We need to square that. Then we're going to have negative 3, subtract now the negative 5, or subtract the 5 I should say. So that's negative 6, which we need to square, plus negative 8, which we need to square. 36 plus 64 is equal to 100, therefore it's on the circle. Okay, in the next part it says the line L is the perpendicular bisector of the chord PQ. In part B we need to show that the line L passes through the centre of the circle. I'm just going to go ahead and just draw a sketch of this. If we have a chord, the perpendicular bisector will run through the centre of the circle. So if we look at the centre of the circle, we got 3, 5, which is just here. So 3, 5. We've got 11, negative 1, and then negative 3, negative 3. So let's put negative 3 here. So that's negative 3, negative 3, and that's the point Q. And then we've got 11, negative 1. So if I put that just here, so 11, negative 1. It looks something like this. Again, it doesn't have to be massively accurate. So what we're looking for now is the following. If we have a chord, and remember a chord is just a line that goes through the from circumference to circumference, but doesn't pass through the centre like a diameter. All I'm going to do is a perpendicular bisector of this and show that it goes through the centre. Now, if we have more than one perpendicular bisector, then we can find the centre of the circle, as this would be the solution to the simultaneous equations of those lines. All we've got to do though is show that it goes through. So for the perpendicular bisector, what we need now is the midpoint just here, and we can do this either in the sort of longer way, or we can just simply go ahead and consider how far we're jumping up. So -3 to 11 is 14. So if I do that, I'm going to get this point here, which is going to be 4. So all I've done is added 7. This one is going to be -2, so let's put on -2, as that's halfway between -3 and -1. So that's the midpoint. We've got a point, now we need a gradient. So I'm going to say that the gradient of PQ, that is going to be the change in y, so it's going to be -1 or -1, subtract -3, over the change in x, which is going to be 11 subtract the -3. So what we're going to get, we're going to get 2 over 14, 2 over 14, which is going to give us 1 over 7. Therefore, we can say now that this line just here, and I'll call this ML, is going to be -7, as ML multiplied by MPQ will be equal to -1 if perpendicular. So we're using this property. When you bisect a chord and you do a perpendicular bisector, that line will pass through the centre of a circle. So y minus y1 is equal to m, the gradient, x minus x1. So we're going to have y minus, and then we're going to have now the coordinate just here, which is going to be -2, so we'll have +2, and that will be equal now to -7, and then we'll have x minus the 4. So we can see from this that y is going to be equal to -7x, and then we're going to have plus 26. So let's show that that passes through. So we got the point 3, 5. So we can say when x is equal to 3, y is equal to -21 plus 26. And we can say that y is equal to 5, therefore it passes through. So that's one particular approach that we can use. The perpendicular bisector of a chord will pass through the centre of the circle. Okay, let's have a look at another question. In question 14, we're told the points A, -2, 12, B, -5, 11, and C, 3, -3 lie on a circle. We're asked to find an equation of the circle. These are the most laborious ones. What we need to do is set up two chords and have the perpendicular bisectors of them, which will get us now at the centre of the circle. Once we've got the centre of the circle, we can go ahead and look to find the radius. So what I'm going to have then is -2, 12. Let's put that on, and this isn't going to be massively accurate. It'll just give us some representation. So let's put -2, 12 there, and that's for point A. -5, 11, let's put that just there. So -5, 11, and that is for point B. And then we're going to have 3, -3, which I'll put over here. So again, doesn't have to be some Picasso-like drawing. We've just got some idea of what's going on. Okay, what I'm going to do here is the following. I'm going to set up some chords, and one chord will be AC, and the other chord, let's put this one on, and let's just go ahead and do that. The other chord is going to be AB. I could do that one, or I could do BC. It really doesn't matter. If I find the perpendicular bisector of this chord and the perpendicular bisector of this chord, then they will both pass through the centre, and we can solve simultaneously to go ahead and find the centre, and then we can find the radius. This is a lot of work. So what I'm going to do is call this M1. The gradient of the chord AB is M1. The gradient of the perpendicular is M2. The gradient of the chord AC is going to be M3. the gradient of the perpendicular bisector is going to be m4. Let's just go ahead and find now the midpoint. If we're doing a perpendicular bisector, we need the midpoint. So this is going to be negative, just looking at negative 5 plus negative 2 over 2 is negative 7 over 2. And then we're going to get 11 plus 12, so that is going to be 23 over 2. If I look at this one, we've got now negative 2 plus 3, so that's going to be 1 over 2, so this is the midpoint, and then we're going to have 9 over 2. So straight away we've got some horrible numbers, but it doesn't really matter. So I found the midpoints of each of these. I'm now going to find m1. m1 will then allow me to get the gradient of m2. So if we look, we're going to have 12 minus 11, and that is going to be now over negative 2 subtract now the negative 5. So that's going to be 1 over 3. So m2 is going to be equal to negative 3. I'd write to the examiner m1 times by m2 is equal to negative 1. So m1 times m2 is equal to negative 1 if perpendicular. Okay, so now finding an equation for the line, we can say that this is going to be y minus 23 over 2 will be equal to negative 3, and then we're going to have x, and we've seen that this is going to be now subtract a negative, so it's going to be plus 7 over 2. Okay, let's tidy this up. Y is equal to negative 3x. Then we're going to have minus 20, what's that going to be? Minus 21 over 2. So minus 21 over 2 plus 23 over 2 should give us plus 1. So that now is the equation of this line right here. I'm going to get the equation of this line, and then we're going to solve simultaneously. So this one right here, what we're going to have is the following. Let's find m3. m3 will be equal to now 12 subtract negative 3 over negative 2 subtract 3. So that's going to be 15 over negative 5, which is going to give us now negative 3. So let's look at these. Let's go ahead and do that. So that's going to be negative. Let's just check that works. That's negative 3. Okay, so let's go ahead and look at that. So that is going to give us negative 3. So m4 is going to be equal to positive 1/3. Okay, that's quite nice and interesting. So if we look at these lines, we can see these two are perpendicular as well. Now, with that wouldn't always happen, but it has in this particular case. So let's go ahead and find a line for this. I'm just thinking if I can do it any quicker, I'll just go through the process we'd have to for any line. Y minus 9 over 2 is equal to now the gradient, which is 1 over 3, and then we're going to have x minus 1/2. So that's what we get, subbing in now the values. So we're going to get on here y is equal to 1/3 x minus 1 over 6, and then if we add this, if I switch this up now into sixes, let's go ahead and do that. So let's just check that's all correct. So let's have a look at this. So negative 2 and this point right here, let's just check I've got this right. So negative 2, that's perfectly fine. That looks good. That's fine. So I'm just looking at the numbers, hoping they're going to come out slightly nicer. So y is going to be equal to 1/3 x, and we're going to have minus 1/6, and then plus now 20, what's that going to be? 27 over 6. So that's what we end up with. That's perfectly fine. So y is equal to, I'm just trying to do this in my head, 1/3 x plus now 26 over 6, which is going to be 13 over 3. Okay, so all we're going to do is set these equal. So we can say, using these to find the centre, minus 3x or negative 3x plus 1 is equal to 1/3 x plus 13 over 3. Multiplying through by the 3, so negative 9x plus 3 is equal to x plus 13. And from here, we're simply going to go ahead now. So what's that going to be? That's going to be, now x is negative 1. So x is going to be equal to negative 1. So there we go. X is equal to negative 1 from there. Hopefully you can see adding 9x and subtracting. X is negative 1. Substituting in, we can see from here that y is going to be equal to negative 3 lots of negative 1, which is 3, plus 1, which is going to be 4. So we can now start writing the equation of a circle. X plus 1 all squared plus y minus 4 all squared is equal to the radius squared. So I found this point now here, and that's going to be negative 1 comma 4. I'm just looking at a property that would allow me to do this slightly quicker at this stage, given these are perpendicular. No problem if I don't have that. All I need to do at this stage is simply go ahead now and find the length of the radius. So to find the length of the radius, I can pick any point. Again, there might be a quicker way. I'm just thinking if there is, but that right there is the radius, and we can go ahead and use the distance formula. So the radius squared, so just writing here, the radius squared is going to be now equal to 3 subtract negative 1, which we need to square, plus negative 3 subtract 4, which we need to square. So the radius squared is going to be equal to, that's going to give me 16 plus, now what's that going to give me? 49. So the radius squared is equal to 65. So all I need to do now is put that back in, and we've done it. So now we can say x plus 1 all squared plus y minus 4 all squared is equal to 65. Really tough question in terms of work done, but we know from our circle theorem that the perpendicular bisector of two chords will meet in the centre. We set up simultaneous equations to find the centre, and then go ahead and find the length of the radius. Okay, question 15. For points A 0, 4, B negative 3, negative 5, and C 6, negative 8 lie in a circle. In part A, we need to prove that AC is a diameter of the circle, and in part B, we need to find an equation of the circle. Right, let's do a quick sketch so it'll help us out. So what we'll have then is now the negative 3, negative 5. So let's put that just here. So this will be the point B. So we'll have negative 3, negative 5. Then we'll have 6, negative 8, which I'll put on just here. So now 6, negative 8. That will be the point C, and then we'll have now some point up here, which is going to be, and I'll put that, let's put that just here, and that's going to be A, and that will be 0, 4. So some rough understanding. Okay, lots of different approaches to this. I'm just thinking of one that we can go for. So what we've got then, if this is a diameter, then the centre, so let's just put this on here, the centre will be 3, and then we will have now, that will be negative 2. So 3, negative 2, and that will be the centre. All I've done is use the midpoint. So halfway between is going to give us this value. So how can we do this? Well, one thing that we could do is use circle theorem and say now that if this is a diameter, then this will be a 90-degree right angle. So what we could say then is that the gradients, one particular way we could do it, is that MAC times by MAB will be equal to negative 1, as now perpendicular as we've got a right angle using circle theorem. What I can also do is find, and if we just call this, let's just call the centre here X, so big X. If I show that XC is equal to XB, which is equal to XA, then we can say that each of these is a radius. Therefore, now, if that length is, let's say, for example, 5, this one is 5, this one is 5, then we can say that it is a diameter. Okay, So let's go for that approach. That's one way of doing it. So let's look at xc. So xc squared is going to be equal to 6 minus 3 squared plus negative 8 subtract now negative 2 squared. So that's going to give me, what's that going to give me? That's going to give me 9, and that is going to give me plus, what are we going to get here? Negative 6, 36. So that's going to be equal to 45. I'm thinking of a quicker way of doing it. I'm just thinking out loud. Xb squared is going to be now 3 subtract negative 3, which we need to square. And then we're going to have now negative 2 subtract negative 5, which we need to square. So that's going to give me 36. That's going to give 6, which is going to be 36. This is going to give plus 3, which is going to give 9. So that 2 is 45. Therefore, we can say now that x is the centre. So x is the centre. I think we might have to do one more. I'm just thinking of it reasonably. Can we get away? I'm going to just do xa. Let's just do xa as well. So xa is going to be equal to 3 minus 0, which is 3 squared, and then plus now negative 2 minus 4 squared. So that's going to be 9 plus 36, which is equal to 45. So we can just say now that that is equal to that, which is equal to that. Therefore, this must be now, we can say that xb is 1/2 now of a to c. And some justification around that. X is the centre, and we can say that xb is equal to 1/2 of AC. Therefore, AC is a diameter. So that's one particular thing. I think looking at the gradients, that would be nicer to do it that way. So that's one approach. The advantage of doing it this way, though, is that I can now find the equation of the circle a lot easier because I've got the centre points. So we can write it now as x minus 3, which we need to square, plus y plus 2, which we need to square. And that is going to give me now the radius squared. And we've already seen that the radius squared is 45. So the advantage of that particular approach is that I had enough information to answer the second part. By merely finding the gradient of these two lines, it wouldn't have given me the information for the second bit. So I've kind of killed two birds with one stone. And as stated, I'm just thinking of different approaches on this to prove that, but I think that's perfectly fine. We define x to be the centre. If it is the centre, then xb will be equal to xa, which will be equal to xc, and we've shown that, and therefore AC is twice xb. I'd write something a bit neater in the exam, but hopefully that does look okay. Okay, let's do another one. A circle has equation x plus 4 all squared plus y minus 7 all squared is equal to 90. In part A, we're asked to write down the coordinates of the centre and the length of the radius. So this is write down. So it's negative 4, 7, and then the radius is going to be the square root, so square root of 90. So if we think about this, what's that going to be? 3 root 10? Let's just write that down. So 3 root 10. You could write root 90, 3 root 10 would be perfectly fine. We're told that points A, negative 13, 10, and B, negative 7, negative 2, lie on the circle. In part B, we're asked to find the area of the triangle ABC, where C is the centre of the circle. So let's go ahead and just draw this up. So we've got now the centre, and that is going to be negative 4. So let's put this on. So we've got now negative 4, 7. Let's put negative 13, 10, and we'll put that just here. Let's put negative 13, 10. So negative 13, 10, that can go there. And then we're going to have negative, so what's this one going to be? Negative 7, negative 2. So that, should we put that one just there? So again, not massively accurate, but it should give us some idea. So this is going to be C, that's C. This one is A, and that one is going to be B. Okay, let's look at finding the area of this. So what we've got then is a chord. So let's put the chord on, and the chord is going to look something like so. Okay, we've also got now a triangle coming up to the centre. What I'm going to do now to find the area of this is first find the length of the chord, which is AB. So let's do that. So if we look at the chord AB, then we can say now that that length is going to be now, so we can say that AB is going to be now the square root of negative 13 subtract negative 7, which we need to square, plus we're going to have 10 subtract now the negative 2, so let's put that on, which we need to square. So that's going to be now 36, that's 6, isn't it? 36, that's 8, plus 64, and that will work out quite nice. So that is 10. So the distance on there, just checking that, negative 13, subtract negative 7 is negative 6, negative 6 squared. Let's just, in fact, this is 12, isn't it? Let's redo that. That one is not right. So let's, that's 144. Let's put that back there. That's 10 subtract negative 2. Yes, 144. I thought that looked a bit nice to come out. So that's 144. So that's going to be the square root of 180. We could simplify the square root of 180. What is that? 12 times by 15. So what's that going to be? 6 root 5. 6 root 5 is 36 times 5. 6 root 5. Yeah, 6 root 5. So let's just put that in like so. So that works out fine. Right, so this is this length right here. So that's the base of a triangle. What I'm now going to do is find the height of this particular triangle here, and we're going to go ahead now and find that. If we look at the type of triangle that we've got, we have an isosceles triangle because this length and this length are going to be the same. Therefore, if I find the midpoint of this line right here, all we're going to do is find the distance now of this perpendicular height. So this is one approach, certainly not the only approach, but it will be a possibility. So this midpoint, again, let's look at the x-coordinates, negative 13, negative 7, so that's going to be negative 10. And then if we look at this one, we've got 10 and negative 2, so that is going to be on there 4. So 10 and negative 2, halfway in between them, that distance is going to be 6, so that's what we've got. So let's now find the perpendicular height of this triangle. So if we do that, let's go ahead and do that. That's that height just there. We can get that by doing the following. So that height, and I'll just call it h squared, or we'll just call it h in fact, because we're going to need it as we go. So negative 10 subtract negative 4, which we need to square, plus we're going to have negative, so let's put that on. That's going to be positive 4, isn't it? Negative 4, that's going to be positive 4. 4 subtract 7, which we need to square. So what's that going to give me? That's going to give me now 10 negative 10. That's going to give me 36. And that is going to give me 3. Negative 3 squared. That's going to give me 9. So that's going to be root, let's get this right, root 45, which we can write. We can break this down. This is going to be 5 times 9, so that's 3 root 5. So the triangle now is going to be the following. Let's go ahead and make the triangle. The triangle, in fact, let's just get a different triangle. That's the one we want. Let's go ahead and do that. As you can see, it's quite a bit of work. What we've got then is the following. That's going to be the height, like so, and we're going to do the following. So this is going to be 6 root 5, so 6 root 5. This is going to be 3 root 5, and then what we're going to have then is 6 root 5 times by 3 root 5 divided by 2. So what's that going to give me? That's going to give me 45. So root 5 times by root 5 is 5. then we're going to have 18 over 2, so that's going to be 45 units squared. Again, check that on a calculator. 6 times 3 is 18 over 2, which is 9. 9 times 5, 45 units squared. Okay, is there an easier way of doing that? Off the top of my head, no, that's quite a tough question, but hopefully that's the adequate setup that we would need to solve something like that. So there we go, another challenging question using circle theorem. So with any of these questions, employ what you know. I didn't look at them before I did them, so it's just a case of what can I use to do them rather than rehearsing them as such.